Hello, it's been a little while since my last one of these videos, and I have been working on the Randomatones since my one-day installation at the Walthamstow Wetlands Engine House on the 2nd of February this year. It was a few months ago. I have been doing mainly software stuff. Actually, I haven't been out much. I've been out once, and there's a recent video about that, about which I will say more some other time. For now, I wanted to have a little look back at this box here, which is the engine house thing that I use, the controller for the speakers, and sort of talk about things from a semi-technical standpoint. I'm not going to start looking at code or anything like that, but I do want to kind of show you what's going on here and talk about what I've been doing. But you may notice, if you watched the earlier videos, that this thing has grown a new roof, and that is the innards of a computer. Now, what's happening here? When I did the installation back in February, not everything went according to plan, really, and one thing that didn't was the Raspberry Pi, which is in there. That's supposed to be the computer for this setup. And its job is to play sounds through the HDMI output, which is in there, and through the amplifier. And it didn't play very well with the HDMI digital to audio converter. It, for example, would play a sound on one channel, then halfway through playing the sound it would cut out and then continue playing the sound on a different channel. And it was just terrible. It did that every few seconds and it was unlistenable. I couldn't use it. When that process had worked perfectly fine on other Linux machines that I've been using here. So I eventually took my big laptop, big down there laptop, and I don't know why I pointed that out, you can't see it. And that was great, because now I had a laptop that was there with its screen open and the various printouts on the screen giving some indication of what was going on and giving something for people to look at and something for me to talk about. So I very much like the idea of having a screen there. I didn't like the idea of having my laptop there because it meant now I was sort of tied to the room, really. I mean, I did go outside for a bit to take a video and just have a little walk around, but not much. I had to be there because that was my laptop with my things on it, and I didn't want someone to walk away with it. So what I wanted really was a machine that I could leave with the installation that was built into it. And so I went to eBay and I spent £15 on the innards of an old laptop. Now, it was broken. Also, the description said it had no mouse pad, it had no hard disk, no battery and no power supply. But it's actually a beautiful piece of hardware, what there is of it. That is my own hard disks that I put on from another machine. And it's great. It works really well. It's not all that powerful. You won't be able to see from here, but those are 4 cores, and you definitely won't be able to see, but that's 4 gigs of RAM, which will not sound a lot by today's standards, but is absolutely adequate, in fact plentiful for what I want to use it for. So what I want to do is just show you a little bit of this. This is the Randomatone setup more or less as it was on the day of the installation. I want to talk about that. But before I do, let's just explain what really is going on there. And we can look at it in a little more detail. There are 3 things really going on when a Randomatone works and plays sounds. The first is that there's a process to generate short note waveforms in files. A couple of seconds or so of a note waveform that's loopable. I know what key I want them. Let's say I want them in the key of A minor. Then I'll make all 7 notes in the scale of in the Aeolian scale of A minor, assuming I've chosen that, and then I'll do some more octaves as well. And those sounds they'll each be different. Some will be square waves, sine waves, mixes of various different waveforms, so that everything's slightly different. If you tell it to make 4, of the A, then it will give you 4 different waveforms of that same pitch. So that's one process, is doing that. There's another process then which takes those short waveforms and loops them up into a long sound, which then applies a volume fade up and a volume fade down at the end. And then the third process is the player, which picks those looped files up at random and plays them and then throws them away. So you've got those three things going on. Let's take a look at them, how they look on the screen. Now, I should just caveat here, an apology. You might be used to watching videos of beautiful screen recordings of computers. I'm running Ubuntu server here, and that isn't possible. There is no screen manager to take a recording from. The only thing I could possibly do is take a feed from one of the monitor outputs and use a tool like this. So that is a VGA output, and this is a VGA input here. And then out of this end, that's a USB port that you plug into your laptop, and this appears essentially as a webcam, and you can record that. I've tried, it looks terrible. It's actually nicer just to point my camera or my phone at the screen right there and show you that. So let's go and have a look at that. Right, well that took me absolutely ages to get the camera in position, and it's still not perfect, a bit on the wonk, sorry, but anyway, this is good enough to see what's happening. So in the top left here is the piece which generates the short note waveforms, and underneath it is the piece that then takes those short waveforms and loops them up into longer ones and applies a volume envelope on it. Now at the moment you can see that both of these processes are doing nothing because they each think that they have made enough files. They both have a maximum pool size of 30. You can see that in the top one because it says so. So having made enough files, they're sitting there waiting for their files to be taken away by the player, and the player isn't currently running. So in a second I will go and start the player, and we'll see that both processes, probably starting with the looper, their files will be depleted and they will start to get busy again. So now let's start the player. I think I can just type that there. And then we will start very shortly to hear some sounds. So you can see now that playing has started. The looper has now got stuff to do, so it's starting to create more looped files because the player over here is using them up. Once it plays them, it takes them away, and the looper wants to maintain its pool of 30 files. So you can see how many files the player has got to choose from. Over here, if you look carefully, choosing from 31 and 30 and 32, and if we leave it in this state, it's possible the looper will keep up, but as the looper creates more looped files, it's using up ones generated by the short file generator, so you can see this one now has a lot of work to do over here to catch up. And so the player is playing through 8 channels of the HDMI. So those 8 channels are sort of numbered, a bit difficult to see, they're numbered 0 to 7 here, but they're all out of order. Because each file is basically a different length. So if you think of what one channel is doing, one channel picks up a file, plays that file to the end, throws it away, and then picks up a new one. And because all the files are at different lengths, then although each channel may start, when you start the playing right from the beginning, it'll pick up, all 8 channels will pick up a file at once. Those files will finish at different times, and they're all very quickly out of sync. In terms of which channel is picking up which file next. But that's pretty much what's happening. You've got those 3 processes there, one making short files up here in the top left, one looping up those short files to make longer ones with the volume fade out, and then the player picking up files and playing them. In terms of what else is on my screen, in the top right you can probably figure out there's a process monitor there, which is telling you how busy the computer is, and you can see it's fairly busy on the CPU front. That'll be these 4 ones at the top here. You know, they are from time to time fairly active, but not always. There's plenty of space in there to do more things, and I'm not using a great deal of RAM. I've got less than 4 gigs here. 3.28 is my maximum on that readout there, and I'm not really using much of it. So I'm quite pleased with this. This is again, as I say, this is a nice piece of old hardware you wouldn't want to be trying to do much web browsing on it these days, but for this purpose it's absolutely fine. And it's even coping fairly well with what's going on down in the bottom left here, which is my recording. I am taking the 8 channels of the HDMI and in software mixing it down to 2 channels, which I'm then recording digitally. That comes at a cost as well in terms of CPU, but not much, as you can see. The machine's able to cope with it. So what I'm going to do now is leave that to run for about an hour, and I will collect the recording that makes and put it alongside some spare footage from another Randomatones video from about a year ago and make a longer running feature. Right, so the plan is now to leave that running for a little under an hour, and I will take the soundtrack that is recording for me nicely, and I will stick it on to some spare footage from the Scout Tunnel in Manchester, which I went to last spring, last February. It was pretty cold, if I remember. I have lots of spare footage from there that isn't actually that great to look at, but what I want to make is just one of these nice hour-long videos that you don't really watch. I listen to quite a few of these when I'm working, and I just have it in my ears and concentrate on what I'm doing. I'm not watching the video, I just want a nice soundtrack to go with it. So I'm going to make one of those out of that. And I will then, next thing I'm going to do, but not now, is show you another machine. So this is a nice £15 eBay purchase. I've got another motherboard over there behind the camera that I didn't have to pay for at all. It's free. My dad gave it to me from a machine of his that was, I think, 20 years old now. It's nothing much more than a motherboard these days. It's power supply, by the way, I used in here for this. So I had to get another one. But it is less powerful even than this. It's got 2 cores and 2 gigs of RAM, I think. And the point there, so we're now getting to what I've been doing over these last few months. I wanted this to run, this technique at least, to run on that machine, but that machine really isn't powerful enough for what is going on here. And there are a few problems with what's going on here that make it too busy. And I wanted to address those and sort of scratch an itch, really, from a technical point of view. So one problem is that this is all, as I explained, file-based. You've got a process writing a file over here, and then another looper process picks that file up and makes another longer file and puts it over here. And then the player is a process that picks that file up and plays it and then puts it over there where it doesn't. And there's a lot of file writing and moving around, which isn't all that costly, but comes at a cost. In system resources, when really the whole thing ought to be able to happen in memory. I should be able to create these files and loop them all up, or just create a long sound in the first place, and do all that in memory and not write it to disk. Which, for those of you who know much about computing with Android, that's not going to actually help your CPU much, because, that's true. But there is another issue as well. The language I have written all this in is Python, which was terrific to get started in when I started with this 5 years ago, when I was programming my first Raspberry Pi and getting it to create files for me using Python. It's all very easy to use Python, but it's quite slow and uses up a lot of system resource, a lot of CPU to do a job that a lower level language, particularly it's compiled to binary machine code, can do faster and with fewer system resources. So I wanted to experiment with rewriting this, basically. Rewriting it to get rid of the files, not have any files at all, just play sounds out of memory and create them in memory, and experiment with using other languages as well. So like I say, I'm not going to show you that now. I think I'll show you that in the next video on that machine over there. We'll either do another screen recording, I don't like that, I'm pointing my camera at it, or I might just bite the bullet and record from a laptop what that thing's doing, which can be done. It's just you're seeing that thing's screen, not that one. I rather like the Ubuntu server layout there. But anyway, never mind. Thanks for watching, see you next time.